Okay, so this will be a video talking about factoring quadratics and then using factoring to solve quadratic equations and then inequality as well. So we'll just kind of start with a couple of factoring problems. Number one here, we have 4k to the third plus 12k squared. So this one actually is not a quadratic, we have a k cubed in there. But one of the things whenever you're factoring is you want to look for is a common factor first. So what I do is just kind of think about how I have two separate terms. I have 4k to the third and then also a 12k squared. And I'm looking to see is there anything that goes into both of those, any common factor, and if so, we want to get the greatest common factor. So I know that 4 goes into both of those, and they both also have at least a k squared. So I'm going to bring out a common factor, 4k squared. That's actually one of the factors. And then factoring again is basically like undoing where we want to turn something into a multiplication problem. So 4k squared is going to get multiplied by something in parentheses there, and we need the answer to be the original expression they gave us. So you're just kind of thinking about if you have a 4k squared out there, how are you going to turn that back into 4k cubed? And I notice that if I times it by another k, right, just kind of distribute that in your head, you get 4k cubed. And then to get the 12k squared, I would need to times the 4k by 3. I'm sorry, 4k squared by 3. And then if you want to check it out, like I said, just distribute it and make sure you get the original term back. And you can always take a peek to the k plus 3 there. Make sure it does not have any common factors. Okay, if it did, that means we didn't take out the greatest common factor the first time. But k plus 3 does not have anything else to divide out, so that one would be done. Okay, number two, a little different. We kind of scan through. I noticed there are no common factors in this one. So this one is kind of a special case where it's a quadratic. It's the a squared. It has 3 terms in it. So this one is kind of going to be like what I like to call like a reverse FOIL backwards kind of thing. So if we just kind of piece together how do we get these terms. To get the a squared, I know it's going to start with a and a, excuse me. And then the trick on these, since it was just one a squared, what we can do, the shortcut method is look for factors of this negative 16. So I need two numbers that multiply to be negative 16, but they need to add up to that middle term, the negative 6. Okay, so you can just start making a list. You know, 16, you think 8s and 2s, so negative 16. Now we need to get the right version here that adds up to negative 6. So I know that the 8 would need to be negative and the 2 would be positive. And then what we do basically with those is those just go in here as the other piece of the factor. And again, this is kind of a shortcut trick method. I'm not going into all the details here, but you could always check these again. If you FOIL that one out, you notice the a times a is a squared. A times the positive 2 is a plus 2a. Then you move on to the minus 8 times a, and then the minus 8 times the positive 2. And just if we kind of just notice just to verify that these two actually do add up to that middle negative 6a like we needed to, it's kind of a good way to check it out. So our final answer here are these two factors. And it doesn't matter which factor you write first. You could do either order. Okay, a couple more, more factoring. So number 3 here, this one is a special case similar to the one we just did. It could be thought of as p squared. Since there's no middle term, you can think of it as like a 0 in there if you want to. And do the same process we did on the previous problem, where we're going to need factors of negative 36 that are going to add up to, in this case, to 0. So it's going to have to be a positive 6 and a negative 6. So we'll go with p plus 6 times p minus 6. Okay, this one's also noted, it's known as the difference of perfect squares, so it's kind of a special case here, but you can think of it like we said with a 0 in the middle as well. Okay, number 4, a little more difficult. It's similar to number 2, but notice the a value, that initial term there is has a 4 coefficient on it. And if we kind of look through, there's nothing in common. There's no common factor in all 3 terms. So the method that I kind of suggest using here is take the a value of 4, and it's going to get multiplied by the c value of 8, so 32. And what we would want to do, kind of like in number 2, I want to split that 32 up, but I need to split it up in the correct way so that its factors add up to the positive 33. Okay, so much like we did in number 2. If you go back up to number 2, kind of think about how there would have been a 1 at the beginning, and we could have done the same thing. 1 times negative 16 would have got us here. Okay, so we're kind of doing the same thing. It's just going to get a little different in a minute here. But back to this one. So I got the A times C is 32. Okay, I need factors of 32, again, that add up to 33. So in this case, 32 times 1, that's going to work. And what I'm going to do, I'm actually going to split this middle term into two terms. Okay, so I have the 4b squared. Here's what I'm going to do. That 33b in the middle is going to split up into these two. It's going to be 32b and 1b. Okay, and then the plus 8 is still sitting there. So I just kind of split that up. Okay, and just kind of notice, make sure we can make the connection. This right here is just equivalent to that. All I did was rewrite the problem using 4 terms so that we can do this method called grouping. Okay, so what we want to do to finish this one is, when, like I said, grouping, we look at our problem now has 4 terms. They don't all share a common factor, but if you take them in groups of 2, meaning take that as a group, and then take the second 2 terms as their own group, now they do each share a common factor. Okay, that first group, 4b squared and plus 32b, they both share a 4b. Okay, and the leftover factor then would be b plus 8. Okay, while the other group shares a common factor of just 1, and the leftover would also be b plus 8. Okay, and now what we actually did, the way we have this set up now, if you notice the red term and the green term, they both now share a b plus 8. They have a common factor in there. So we can bring that b plus 8 up front. Okay, they both had the b plus 8, right? And then the leftover stuff is just the 4b and the plus 1. Okay, and this thing is actually factored. You could check it out if you want to take a second, FOIL it out, make sure you see it. But yeah, that would do it. Okay. All right, number 5 here, we want to solve an equation by factoring, and it's going to be similar. It's similar to one we just did because it has a 3 as a leading coefficient. So we're going to have to do the same method. So let's do that. Let's factor this first. We're going to do the a times c, right? 3 times 6 is going to give me 18. Okay, now I'm going to need factors, excuse me, of 18 that add up to negative 19. So in this case, to get positive 18, I would need to use a negative 18 and a negative 1. Okay, so let's split up that middle term same way. We go minus 1n minus 18n. Okay, and it doesn't matter which order you do this in. I could have put these two in the other order if you wanted to. It would still work out completely fine at the end. So whatever you want to do, it doesn't have an impact on your final answer. Okay, but if we did it this way, then we could say, all right, these two, the 3n squared minus n, they only share a common factor of n. And what would you have to times n by to get back where we were? So it would get multiplied by 3n and minus 1. Okay, in the second group, we have that minus sign in the middle. 18n and then a 6, they share a common factor of 6. Okay, and its leftover would be 3n minus 1 as well. Okay, and again, check that out by distributing. The minus 6 times 3n and the minus 6 times the minus 1 does get me positive 6. Okay, so that leaves us with a common factor, 3n minus 1, and then n minus 6. Now just remember, all along here, this was an equation. This had an equals 0 on the end, right? So this was a little different than what we did in the previous problem because we have that equals 0 up there. So the only extra step we need to do now is that since we have it factored, there's this property called the zero product property that basically says if you have something times something else and it equals 0, then we know, like if you think about it, the only way you're going to get 0 is if one of those things was 0. So what we do now is just take each factor individually and set them equal to 0, and we're going to solve both of them and get our two answers. Okay, so n could be positive 1/3. Okay, we're actually solving an equation here. Oops, n minus 6 equals 0 there, and n equals positive 6. Okay, and those would be the two solutions that would solve the original equation. Okay, we're not just factoring, we're using factoring to solve an equation. Okay, and then finally, we can do something similar here. We can solve an inequality. And remember the steps here. I kind of give you use the spit method, I like to call it. We're going to solve the equation, and then we will plot, and then we'll do an interval test. So that's where the spit method comes from. I'm going to solve the equation by factoring. Okay, similar to one of the previous problems, I'm looking for factors of 40 that'll add up to negative 13. So it sounds like negative 8 and negative 5. B minus 8, B minus 5. Okay, and I'm writing less than or equal to, even though technically we're solving it as if it were equal to. But what I'm going to be able to do now is actually solve the equation. B minus 8 equals 0. I'll get B equals 8. The other factor equal to 0 give me B equals 5. Okay, now those are not the solutions. Those are, since this is an inequality here, those are going to be called our critical values. Okay, if this was an equation, we'd be done. Okay, but it's not. Inequality. So what we do with those is we plot those on the number line. Okay, so I have 5 and I have 8. And what it ends up doing, it ends up dividing the number line into 3 different intervals. Okay, anything less than 5, anything in between, and anything bigger than 8. And what we need to do, we actually need to do a test point from each interval. We're going to test 1 point from each. And when I say test, we're going to plug them into this and see if it's true. Okay, so let's take a look. Let's do something from interval 1. I need to test a number less than 5. Let's test 4. What if b equals 4, right? And you have options here. You can plug it into the original if you want to and see if the answer is less than or equal to 0. I kind of tend to like going into the factored form, the highlighted blue there, and just worry about things being negative or positive. So again, the thing we're testing into is b minus 8. I'm just going to write this one more time, times b minus 5 being less than or equal to 0, and we're going to check. So if b is 4, b minus 8 then would actually be a negative number. Okay, if b is 4, the second factor, b minus 5, would also be negative. And we know a negative times a negative is a positive. Is that less than or equal to 0? Is a positive number less than or equal to 0? No. Okay, so when you use the factors, you don't really need the specific numbers. You just need to worry about, is it positive or negative? So I know that interval 1 is not the solution. For interval 2, test any number between 5 and 8. Let's test like b equals 6 or something. Okay, so when I go to plug that into the 2 factors, if b is 6, b minus 8 would be negative. Okay, b minus 5 would be positive. Okay, a negative times a positive is negative. Is that less than or equal to 0? A negative number? Yeah, that is. So interval 2 is good. That's working. It works. Anything in between 5 and 8 is going to work. All right, and then we just need to do our final interval. Interval 3 up here on the right is anything bigger than 8, so why don't we test 9. If b is 9, go into the original again, into the factors. Okay, so I'm going up here, b minus 8, 9 minus 8 is a positive. 9 minus 5 is a positive. Oops, we need to do a greater than or equal to. Is a positive times a positive, sorry, we need to do a less than, is that going to be less than or equal to 0? Positive times positive is positive. Is positive less than or equal to 0? No, it's not. That interval did not work. Okay, so we know the only numbers that worked were between 5 and 8. So everything between 5 and 8. Now the actual values of 5 and 8 themselves do actually work in this case. And that's because we have this, is it greater than, I'm sorry, is it less than or equal to 0? Okay, at 5 and 8, the y value actually is 0. So it does equal 0. So it works there. So we can have a closed circle. So our solution, if we want to write it just a couple different ways, we have the number line where we shaded the region. You could write it as an inequality saying 5 is less than or equal to b, less than or equal to 8. That'd be in inequality notation. So that's one option. Or you could write it in interval notation using the square brackets, saying any number between 5 and 8. Okay, so that's that. And that is a review on factoring and using factoring to solve equations and inequalities.